here's a little recap. You will recall in the previous explorations that all of our rational functions had degrees that were greater in the numerator than in the denominator. And the numerator degree was all greater by 1 degree, which is linear, which means we got a line for our oblique asymptote. So let's look at these last two explorations. Here's number 4. Let's take a look at the function. 3rd degree in the numerator, 1st degree in the denominator. What's the difference? 2. So a 2nd degree is not linear, it's quadratic. And what's the shape of a quadratic? A parabola. So I think we can predict that our asymptote will be parabolic shaped. Okay? So let's do it. Let's use long division to rewrite our function as a quotient and a remainder. Now we're dividing by a linear binomial. Should we use synthetic division? I agree. So if we're dividing by x minus 2, we want to change the sign to 2. And then we want to use the coefficients of each of the terms in the numerator. So 1x cubed, negative 2x squared, 0x plus 3. So now we can do our synthetic division, drop the 1, multiply times 2. We get 0, 2 times 0 is 0. Combine, we get 0. 2 times 0 is 0. We get remainder 3. So g of x is equal to, let's see, we start at x cubed, so this would be x squared plus 0x plus 0, so x squared, and then remainder 3 over the divisor, like that. Yes? Okay, so what happens as x gets really big? Well, this remainder here has an x in the denominator. As x gets really big, the value of the remainder goes to 0, and our function g of x acts like x squared. So that should be our asymptote. So let's graph and see what happens. So y equals, I'm going to clear my equations, whoops, and we need to put parentheses around the numerator. So x to the 3rd minus 2x squared plus 3 divided by parentheses x minus 2. And then we think our asymptote is going to be x squared. So, here's the graph. Oh, that's no good. My window is set wrong. Yeah, I need to do a zoom 6 to reset my window. Zoom 6. Here we go. Okay. Well, the red is the parabolic asymptote, and the blue is the function, but I think we're missing some. So I'm going to, go to the window, and I'm going to increase my y max to 40, and I'm going to reduce my x max to 6, and see if that helps us see a little better. There it is. So, very cool. Let's see if we can make a graph of this. First of all, are there any vertical asymptotes? No. It looks like there's one here. Are there any roots in the denominator that cause it to be 0? 2. So there's a vertical asymptote at 2. So 1, 2, vertical asymptote there. And then, before we graph the function, let's graph the parabolic asymptote. So I'm going to press the trace function. And do you notice in the upper right-hand corner there's an equation up there? Is that the function or the asymptote? It's the function. So if you want to get to the asymptote equation, do the down arrow and see how it changes. So now we're on that. So I'm going to put, now that we're on the asymptote, I'm going to do 0, enter, and I'm going to get a coordinate for the parabola. And then I'm going to go 1, enter, and get another coordinate for the parabola, 1, 1. 2, enter, so 2, 4 is another coordinate. Let's see, 3 will be 9, so 4, 5, 6, 7, 8, 9. I don't think we can get any more on. And then you can do the same in the other direction, but it's symmetric, so you can just reflect your points across the y-axis. All right. Well, now that we have the asymptotes on our paper, let's draw the function. And it looks like it comes down along the parabola, crosses the y-axis, and then follows the vertical asymptote downward. And then it flips over the vertical asymptote, and it comes down a little bit, and then it follows the parabolic asymptote back up. So we did it. I think that's pretty cool. So we do one more, and then we'll practice the rest of the hour. Okay, looking at this function, the numerator is degree 4, the denominator is degree 1, so the difference is degree 3, which would mean a cubic asymptote. How many turning points could a cubic asymptote have? 2 or 0. How many x-intercepts could it have? 2, 1. Can it have 0? No, because it's odd. Okay. Okay, so degree 4, degree 1, it's a cubic. Let's do the division. We can do synthetic because we're dividing by a linear binomial. So 3, let's see, 1, negative 3, x squared is 0, x is 0, and then a plus 6. Aren't you glad you learned synthetic division?
Yeah.
Yeah. Why is it 0? Okay, yeah, you have to, it's like, who did I say yesterday? Here's why you need the zeros. Justin, I'm going to give you a $100 bill. Are you ready?
Yeah.
There it is. Because zeros don't mean anything. All right?
I'll take $1.
So they're important. You have to include them all. All right. I love doing that. All right, let's see. Drop the 1, multiply, combine, multiply, combine, multiply, combine, multiply, remainder 6. Well, that looks kind of crazy. But we started with x to the 4th, so that's just an x third. So in divided form, quotient remainder form, the quotient is x cubed, and the remainder is 6 over x minus 3. And as x goes to infinity, that goes to 0, so h of x is approximately equal to x cubed when x is big. Yeah. So let's go back in here, and we'll do a little graph, parentheses, x to the 4th minus 3x cubed plus 6, close parentheses, divided by x minus 3. And then x to the 3rd is our asymptote. Hey, are there any vertical asymptotes?
Yeah. Probably. Yes.
Yeah, positive 3. So I'm going to draw that in. That one's easy. Okay, here we go. Here's the graph. Oh, and I forgot to do the zoom 6 again. Crapper. That is pretty cool looking.
It is. Oh, look at that.
All right, well, I'm going to change the window here a little bit. I'm going to go from -5, maybe up to 10, and then the y's, let's go -5 to 40. That'll be all right, and let's see what happens. Hold it, what did I do wrong? That should work. I don't think we went up high enough yet. I'm going to go Y max 100 because I know there's more. There it is. Okay. And then I'm going to do the Y min a little bit more too, so we can really see it good. There we go. Groovy. I'm going to press the trace button. Right now I'm on the function. I'm going to do the down arrow to get on the asymptote, and I'm just going to plug in some numbers like 0. So the asymptote goes through 0, 0, at 1, 1 and 1, 2 and 8, 2 and, actually, yeah, 2, 2, 3, 4, 5, 6, 7, 8. 3's off the chart. That's a bummer. -1 is -1. -2 is -8. 2, 4, 6, 8. You know what? I don't like how this is looking, so I'm not going to do it to scale. I'm just going to draw a sketch because we really can't see it very well otherwise. and it looks like we have part of the function up here, and then it looks like it goes up like that. Sometimes you can't draw to scale, and you just have to make a sketch. And that's what we're doing there.
If we did that on a test.
Yeah, if you did that on your test, that's fine. Yep. All right, that is it.